Hello, this is Professor Salahat, and in this video, I'll try to work on the homework 6, and I'm going to start with or continue working here and work with number 20. In number 20, it says decide whether the normal sampling distribution can be used. If it can be used, test the claim about the population proportion P at the given level of significance alpha using the given sample statistics. And they gave us already a claim, and they gave us sample statistics, and so they gave us a summary of what's happening here. There is a condition in statistics, and that is when we deal with proportions. Now, in order to use the normal sampling distribution, the condition is that both NP and NQ, and again, NP is equivalent to the number of yeses. So the proportion of the people who say or who agree or say yes times the number of people who would say yes, that will give me the number of the yeses, and NQ is the number of the no's or no. Now those two numbers, to avoid bias, in this case, both of them has to be at least greater than or equal to. So both of them has to be greater than or equal to 5. That is the condition in statistics. Again, to avoid bias. So from looking at this problem, we can tell that yes, because both NP and NQ are equal to 5 or greater than or equal to 5. And the reason is, if we look at the problem here, why we chose this is we know that N is equal to 100, because they say in here N is 100. And we know that P, the proportion, is equal to 0.24, okay, in the sample. And the Q will be equal to the complement, which is 1 minus 0.24. Let me erase that, which is equal to 0.76. So when we take NP, we'll take 100 times 0.24, which is 24, which is greater than 5. When we take NQ, which is 100 times 0.76, which is 76, which is greater than 5. So in other words, in this problem here, the number of people who said yes is 24, and the number of people who said no is 76, and as a result, they are both greater than or equal to 5. Now, let's check our answer and go to the second part of the problem. The second part of the problem says, okay, since you are able to and you can work with this problem, tell me what is H naught is and what is HA. By looking at the problem, this is a proportion problem. Again, we know they told us that this is a claim about a proportion. Let me stop here. Claim about a proportion and a population proportion. And then in the claim, they said is not equal. So if we go down here, what it says claim, it said not equal. So not equal means, we are supposed to put not equal with HA, not H naught, and complement or the opposite of not equal is equal. And in the claim, it says 0.25. So we put 0.25 in here and 0.25 in there. And in this case, we're going to write the word claim. So we're going to write the claim next to HA because they told us this is the claim. So we're going to go in here and try to find it. And it's part C, equal, not equal. The next part of the problem will be determine the critical values and select the correct choice. So to find critical values for a proportion is like for mean when sigma is known. Same steps. So in other words, we're going to go through this stat, calculators, normal, and we don't pay attention to the mean, because the mean is going to be 0, the standard deviation is going to be 1, but we need to look at, and again, let me make sure that you pay attention to this, we need to look at HA. HA here has not equal. Not equal means you're going to have something like this with a two tail. So there are two tails to this problem. So if there is two tails, I'm going to press between Then I'm going to go to last box and fill the last box with 1 minus alpha. That is the condition. Remember, if it's one tail, just put alpha. But if it's two tail, you put 1 minus alpha. So in our problem here, alpha is equal to 0.01. So this is going to be 1 minus 0.01. So let's try to go in there and find the answer here for the critical value. In this case, we're going to get two of them because one is going to be in the left, one is going to be in the right. So when we go here to stat, calculators, go down to normal. Again, because of two tails, we're going to put between. And we're going to go to the last box and put 1 minus 0.01 because that's alpha in the problem. And notice that I get two criticals, one in here, positive, and one is negative. So there are two criticals. So I can write the two critical, again, it's going to be z criticals. I can write them like this, negative 2.5758, comma, 2.5758, or I can write them like this, plus or minus 2.5758. Let's see what they want us to do in the problem. This way we would fill that. So in this case, it says the critical value or values is an R, and it says round to two decimal places and use a comma. So they want us to express that as shown in the first here. So they want us to use a comma between, but they want only two places. So let me just show you that this is how far they want us to go. So in this case, if I want to write this, the first one was going to be negative 2.58. Let me click in the box, 2.58. When I round it, then I put a comma. Then I put the second one, which is 2.58. Now we need to check the answer. The next step will be we need to find the z-test statistic. Again, to find the z-test statistic, I have to, with a proportion, I have to follow those steps. I have to go to stat. I have to go to proportion stat. Then I'm going to go to one sample and with summary. And from there, I'm going to fill number of successes or number of success. And let me just write successes in here. And number of observations. Notice that the number of observations is always equal to n, and number of successes is always equal to n times p. Sometimes we are given the number of successes. By the way, success is the same as the number of yes. So sometimes we are given, sometimes we are not. So let's look back at our problem and see. In our problem, they gave us p hat. So they gave me, by the way, this is, I'm sorry, this is a p hat. They gave me the p hat. They didn't give me the number. They gave me the proportion. So as I did earlier, if they give you the proportion, you just multiply to get the number of successes. So in this case, in our problem here, the number of successes will be equal to 20. We did that earlier. It's equal to 24. Again, how we know that? We take the p hat, which is 0.24, and multiply it by n, which is 100. So an n in the problem that gave me is 100. So if I go to StatCrunch and just fill in all the information that I have, again, let me go back, start from the beginning. Stat, proportion stat, one sample. And again, I go with summary. And number of successes is 24. Number of observations, which is 100. And I need to fill in the test. And notice that the test is the test earlier here. So I just need to match that test. This is going to be 0.25 and not equal 0.25 and hit compute. And that is the z-stat that they're looking for. So the question is asking us for a z-stat. So this is the z-stat. Z-stat is equal to negative 0.23094. And actually, there is another thing called p-value. Let's just capture that in here. The p-value, which is the value next to the z-stat, which is in here, which is 0.8174. So let me go back to the problem and see what they need to do. They're asking me to find the z-stat up to two decimal places is going to be negative 0.23. and then they asked me just to run the test. So they're not asking me for the p-value, but I needed the p-value for a good reason. I'll tell you why. Now, the p-value in this case, and we have alpha. The p-value is 0.8174, and alpha is given in the problem. Look at the problem, the question there, it says 0.01. Now we know that the p-value is bigger than alpha, and we have a rule that we have to remember all the time, that if the p-value bigger than alpha, fail to reject H note. So we're going to fail to reject H note. Now, if you fail to reject H note, what happens? Let's go back up to the problem here. Here is my test. Let me just slide it to the right. Here's my test. So in my conclusion here is I'm going to fail when H note in here, fail to reject. And the opposite will be, the decision for HA will be opposite, so reject. But which one of the two statements is the claim? The claim is, let me shrink this, the claim happened to be HA. So as a result, in this case, we're going to take the decision in here to reject the claim. So the conclusion here is reject H note. Let's look at options A, B, C, D, or E. Notice that in A and D, reject H note. We're saying don't reject H note. So it's going to be either B or C. Fail to reject H note. The data provides sufficient evidence to support the claim, or the data does not provide or do not provide sufficient evidence to support the claim. Notice that the data does not provide enough evidence to support. That's the reason why we are rejecting. Because if the data provides enough evidence to support, then we'll support the claim. So it's not B, it's the C. Because in C, we are saying we do not provide sufficient evidence to support. Again, it's equivalent to reject. So let's check the answer. And that's the correct answer. Now let's go to the next one. The next question is, talking about a medical researcher says that less than 78% of adults, when the medical researcher says is the same as claims. So this is the claim. The claim in the problem is that less than 78%. So when we're talking about 78%, we talk about the proportion. So the proportion is less than, I'm sorry, I'm saying 78, 87. 87% or 0.87, 87%, which is the same as 0.87. That is what the researcher is claiming. Claiming that less than 87% of adults in a certain county or country think that healthy children should be required to be vaccinated. In a random sample of, so this is what we did. We took a random sample of 400 and adults in that country, and this is what we found. P hat, which is the proportion in that sample, which is 0.83, think that healthy children should not, I'm sorry, let me repeat the problem. It says in here, a researcher says that less than 87% of adults in a certain country think that healthy children should be required to be vaccinated. In a random sample of 400 adults in that country, 83% think that healthy children should be required to be vaccinated. Okay, so the p hat is 83%. At alpha equal to 0.0 or 0.10. Remember, this is not a 10. I'm sorry, it's not a 1, it's a 10%. Is there enough evidence to support the researcher's claim? So if I want to write this statement, I will write it like this one. H note and HA. Both of them is going to be about P. And the first one is talking about 87. The second one is talking about 87. But one is saying less, so the less goes in the bottom, and the opposite of the less goes in the top with equal. So this is how we write the statement. Again, because this is less, it goes in the bottom. Now let's try to answer the question in here. It says identify the claim and state H note and HA. Notice that the claim is the bottom statement. So what is the claim? The claim, let's look at A, B, C, D, whatever. The claim A says less than a % of adults in the country think that healthy children should be required to be vaccinated. and that is really A. It is 80, because remember, they put percent, we're going to put that as a percent. If they did not put the sign percent in here, I put this as 0.87. We cannot go beyond that, because it's the second one, it says the percent is not. It didn't say is not. The third one, it says 87% of adults in the country think that 87% of adults means equal to 87, which is not true for part C. And for part D is also not true, because it says more than. So the one that is the correct answer is A, because it says less than. Let's go to the second. The second thing in here, we're going to choose H note and HA. So I wrote that already. So we're going to choose greater than or, and here's E, that will match, greater than or equal, less than, and it's going to be 0.87. And never write a percent in the test itself. Convert that to a decimal. It's going to be 0.87. So we check the answer. And the next step will be find the Z0. Z0 is the same as Z critical. To find Z0 or Z critical, given two things, alpha equal to 0.10, and we have a, notice that in here, because if you look at HA, it has a less. Less means left tail. So we have a left tail, and we have alpha equal to 10%. So let's go back to StatCrunch, and we do this. We go to stat, and again, calculators, because critical is always calculators. Normal. And notice that this is a left tail, so this is here is a left, so just keep it left, and just go to the last box and put in there the 10% that they are giving us for the answer. Notice the picture confirms this is a left test and gives us the critical value. Now in the problem here, they want the critical value to two places only, so it's going to be negative 1.28. We're going to stick with, I'm sorry, it's not writing here, negative 1.28. So I'm going to copy this number just only to two places. So when I check the answer, it gives me the correct answer. The one after that is identify the rejection region. Notice that the red region is that rejection region. So the red region is, the rejection region is when Z is less than, we're not going to go with more or between, just less than negative 1.28. Anything less than negative 1.28 will be rejected. The question after that is, what is the standardized test statistic? So to find the standardized test statistic, I have to go through the steps. Let me move this around here. I'm going to go through the steps that we mentioned in the previous example. And those are the steps. So we're going to go to stat. And we're going to go to proportion stat. Again, let me repeat this. Proportion stat, one sample with summary. And let me go back to my problem here. Here's my problem. I need the number of successes. So what is the number of successes? From here, number of successes is equal to n times p hat. So we know that n is equal to 400. And we know that p hat is 0.83. So if you have a calculator or grab a calculator close to you, 400 times 0.83, that's going to give us a total of 332. So that is going to go in the number of successes, which is 332. Now what goes into the number of observations is n, so it's the 400. And now we want the test to match. So here's our test. The percent here is 0.87. And it is the less, so we're going to choose the less. So when we choose the 0.87 and the less and hit compute, that's going to give us, let me write this down here. It's going to give us the Z stat to be equal to negative 2.3788 and the p-value, which is next to it, to 0.0087. Notice those values are here in this table. Now, I'm done with StatCrunch. I go back to my problem. They want me to find the Z stat to two decimal places. It's going to be negative 2.378. I'm going to write 8. And again, because there is only one of them. Again, why there is only one? Because this is a again here, because this is a left test. A left test has only one. This is the Z critical, or we call it Z0 sometimes. So let's check the answer. Now the next step will be taking the decision in here. Decide whether to reject or fail to reject the null hypothesis. We have to be careful in here. Let's go back to our test. Notice that I need to take a decision. So my decision, and I like always to take a decision based on p-value and alpha. Alpha in the problem is 0.10, and the p-value is in the problem 0087. Let me erase that. Again, here is the p-value. We can tell by looking at this that the p-value is too small. If the p-value is too small, we're going to reject H0. So we took a decision to reject H0. Let me go back to my claim on my statements in here. Here's my statement. Here I'm going to write reject. But notice that this is not my claim. My claim is, let me narrow this. My claim is the second one. So the second one is fail to reject. So this is my decision, to reject H0 and not reject the claim. So decide whether to reject or fail to reject the null hypothesis. So in this case, we will reject the null hypothesis. So if you reject the null hypothesis, there is or is not enough evidence to reject or support the claim. Notice that we may approach this two different ways. Let me just show you the first way. Many of us will say, okay, when we reject or when we fail to reject a claim, we are not supporting the claim. It's just we are saying that we fail to gather enough evidence to reject the claim. Like, take the example of the justice system. When you fail to convict somebody, it doesn't mean that they are innocent. It is just the evidence that we collected is not good enough to convict that person. So there are two ways to approach this. So somebody may say there is enough evidence to support the researcher's claim. Now, this is equivalent to saying there is enough evidence to find the person innocent. If you check the answer, it's going to be okay. Now, somebody may say there is not, again, so this is, again, the idea in here, if you fail to reject, then you're going to say, okay, I have enough evidence to support. But somebody can look at it from a different point of view and say, no, again, this is gone. But no, there is not enough evidence to reject the claim. So in my opinion, both are correct, but I prefer, and they prefer, this approach. Like, if you fail to reject, then you are supporting. Okay, so I'm going to stop here to make the videos short to load, and I'll continue with another video with the remaining problems.